Welcome, everyone, to today's explainer. Have you ever been deep in a crucial task, maybe a massive deployment or a vital remote meeting, and suddenly everything just stops? Your connection drops. It's a completely universal pain point, but fixing it doesn't require guesswork. It just requires a solid understanding of our RF environments and a systematic approach to isolation. Actually, fun fact for you, a massive percentage of those panicked, the Wi-Fi is down, IT tickets actually end up being simple ISP DNS failures. So today, we're mastering access points and wireless diagnostics. We're going to decode the signals, map out the hardware, and give you the absolute ultimate troubleshooting roadmap.
Okay, let's dive straight into this. We'll be looking at bridging the wireless gap, identifying Wi-Fi signal killers, Wi-Fi versus internet issues, and finally, a tech triage checklist.
The Wi-Fi is down. We've all heard it, right? If you work in tech support, IT, or honestly, even if you're just the designated sysadmin for your own family, this is the classic panic-inducing complaint you hear all the time. It's a phrase that instantly spikes your blood pressure. But here's the thing. Mastering this diagnostic process is absolutely crucial because that single sentence is almost always technically inaccurate. By the end of this explainer, you're going to know exactly how to prove it, and way more importantly, how to fix the real issue. Section 1. Bridging the wireless gap, from cables to freedom. Our modern infrastructure is basically a clash of desires. Think about it. Network switches and routers absolutely thrive on deeply reliable, hardwired physical cables. But our laptops, our smartphones, they crave mobility. An access point is what bridges that exact gap. It acts as the ultimate translator, taking those physical Layer 2 Ethernet frames and converting them into invisible 802.11 radio waves. Without that AP, your mobile devices have literally no way to interface with the wired backbone. Now, residential APs are usually just built directly into your ISP's all-in-one consumer router, but enterprise APs, that's a whole different ballgame. They are separate, dedicated, and often controller-managed hardware units built purely for high-density RF coverage. You'll usually spot them mounted up on ceilings or walls. Grounding yourself in exactly which environment you're dealing with dictates your entire troubleshooting approach right out of the gate. Moving right along to Section 2, identifying Wi-Fi signal killers, environmental constraints. Always remember this, Wi-Fi isn't magic, it is physics. It is so incredibly easy to think of Wi-Fi as this magic, invisible cloud of internet that should just be everywhere at all times. But as technicians and problem solvers, we have to remind ourselves that radio waves are subject to the strict, unforgiving rules of the physical world. They do not just magically pass through everything untouched. So identifying exactly what degrades these signals is crucial. First up is distance. And this isn't just a slow linear fade. It's a massive exponential drop-off in the signal-to-noise ratio. Then we have physical obstacles. Concrete causes severe attenuation, often just straight-up blocking signals entirely. Heavy metal structures like filing cabinets or steel beams act like mirrors. They reflect RF, causing destructive interference. And thick glass, it literally absorbs the signals. These environmental constraints are the hidden signal killers, causing dropped connections and frustrated clients every single day. Which brings us to Section 3, Wi-Fi versus internet issues, the great confusion. Now, what's really interesting here is the critical distinction you have to make right away. A true Wi-Fi issue is a local link failure. That means you'll see a missing SSID, a grayed out icon, or severely low bars. The invisible bridge between your device and the access point is fundamentally broken. But an internet issue, that is an upstream failure. You've got full, strong Wi-Fi bars, your device says connected, but web pages are just timing out. In that scenario, the Wi-Fi itself is actually perfectly fine. When a device says connected, no internet, your Layer 2 wireless bridge is flawless. The exit door, the gateway to the wider world, is what's actually failing. If you see full bars but absolutely nothing is loading, you must immediately stop looking at the AP. Don't waste time worrying about concrete walls or RF interference. The problem lies further upstream, so you need to start looking at the router, the modem, or the telecom line coming straight from the internet service provider. Finally, let's jump into Section 4, the Tech Triage Checklist, Pro-Tech Field Protocol. Step 1. Use your eyes. Check the physical AP hardware lights and the SSID visibility. Literally look up at the ceiling. If the lights are dark, you likely have a power or hardware failure on your hands. Next, cross-verify. If your phone connects perfectly fine, but a user's laptop doesn't, boom, you've just isolated the fault down to the client device. Finally, analyze that connection string. You need to determine if you should troubleshoot the local link or pivot entirely and check the upstream gateway. You need to make isolate before you reboot your daily technical mantra. I know, it is so tempting when things go wrong to just walk over to the closet and blindly pull the power cord out of the wall to restart the whole shebang. But when you do that, you destroy logs, you wipe out error codes, and you burn the evidence. Use your brain, follow the triage protocol, and isolate the exact point of failure first. Only then can you actually fix it right the first time. So, here's a thought to leave you with. Next time a connection drops, a deployment times out, or you hear someone down the hall yell, "The Wi-Fi's down," what are you going to do? Will you automatically blame the Wi-Fi, or will you check the exit door? You now have the knowledge to see the RF environments around you, isolate the true faults, and solve the problem with absolute precision. Keep exploring, stay curious, and I'll catch you in the next explainer.